everyone, welcome in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. In this session, we are going to start the new chapter which is projection of points and straight lines. Topics which we are going to learn in this session are projection and types of projection, difference between orthographic, oblique and perspective projections, principal projection planes, arrangement of principal projection planes and various possible location of a point. Let us start with projection and types of projection. What is projection? In engineering drawing practice, the representation of an object on the two-dimensional plane is called projection. Here, types of projections are given. There are two types of projection, parallel projection and perspective projection. In parallel projection, projection lines are parallel to each other and observer at infinite distance. In perspective projection, projection lines are non-parallel and observer is at finite distance. Now, there are two types of perspective projection, linear and actual. Linear divided into three parts, 1-point projection, 2-point projection and 3-point projection. Now, there are two types of parallel projection, oblique and orthographic. In oblique projection, projection line parallel and inclined to plane of projection. And in orthographic projection, projection lines are parallel and perpendicular to plane of projection. Now, there are four types of oblique projection, cabinet, cavalier, clinographic, shade and shadows. Now, there are two types of orthographic projection, multi-view projection that is two-dimensional and axonometric projection that is three-dimensional. Now, there are four types of multi-view projection, first angle, second angle, third angle and fourth angle. Now, there are three types of axonometric 3D projection, isometric in which equal angle of three face, dimetric in which equal angle of two face and trimetric different angle of three face. Next, let us understand difference between orthographic, oblique and perspective projection. Here, orthographic, oblique and perspective projections are given. You can see here, in orthographic projection, projection line from all corner point of the object are parallel to each other and perpendicular to plane of projection. So, this is the orthographic projection of this object. In oblique projection, projection line from all corner point of the object are parallel to each other and inclined to plane of projection. So, this is the oblique projection of this object. In perspective projection, projection line from all corner point of the object are non-parallel and converging at station point P where eyes of observer is located. So, this is the perspective projection of this object. Now, perspective projection is used in building drawing. Next, let us understand principal projection planes. There are three principal or reference projection planes. First, horizontal plane. It is denoted by H dot P or HP. A plane parallel to the ground or the floor is called horizontal plane. To have projection of the object on this plane, the object is viewed from top. The projection is known as the top view or plan, and top view or plan of the point is denoted by small letter of A, B, C, D. Next, vertical plane, it is denoted by V dot P or VP. A plane perpendicular to the horizontal plane is called vertical plane. To have projection of the object on this plane, the object is viewed from front. The projection is known as the front view or elevation, and front view or elevation of the object is denoted by small letter of A dash, B dash, C dash, D dash, etc. Next, third plane is profile plane. It is denoted by P dot P or PP, a plane perpendicular to the horizontal plane and the vertical plane is called profile plane. To have projection of the object on this plane, the object is viewed from the side of the object, either left or right. The projection is known as the left or right side view, and the side view of the point is denoted by small letter of A double dash, B double dash, C double dash, D double dash, etc. Next, let us understand arrangement of principal projection planes. Here you can see horizontal plane which is parallel to ground or floor, vertical plane which is perpendicular to horizontal plane, and profile plane PP which is perpendicular to vertical and horizontal plane. Now, when we observe any object or any point from front direction, then we will get its projection on vertical plane, and it is known as front view or elevation. When we observe any object from top direction, then we will get its projection on horizontal plane, and it is known as top view or plan. Now, when we observe any point or object from left direction, then we will get its projection on profile plane, and it is known as left side view. So, this is the 3D arrangement of three principal projection plane and its views. For 2D projection, we need to rotate horizontal plane in clockwise direction up to 90-degree angle and profile plane on right side of vertical plane up to 90-degree angle. So, this is the position of horizontal, vertical and profile plane after rotation of horizontal and profile plane. This is the actual pattern of views and planes in orthographic projection. Now, in orthographic projection, we need to draw front view, top view and side view with reference to XY. XY is a common intersection line of horizontal and vertical plane. Next, let us understand various possible location of a point with respect to HP and VP. Here, this is horizontal plane and this is vertical plane. The common intersection line of horizontal and vertical plane is denoted by XY. Now, there are four quadrants made by this horizontal and vertical plane. First quadrant, second quadrant, third quadrant and fourth quadrant. Now, this is the 3D presentation of four quadrants. If you want to draw its 2D presentation, then we need to observe this figure from this direction. So, horizontal plane we can see as a horizontal line and vertical plane we can see as a vertical line and XY line we can see as a point. So, this horizontal line in 2D figure indicate horizontal plane, this vertical line indicate vertical plane and this point indicate XY line which is the common intersection line of horizontal and vertical plane. Here, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now, how to define any point with respect to horizontal and vertical plane? With respect to horizontal plane, any point is defined either above HP or below HP or on HP. With respect to vertical plane, any point is defined either in front of VP or behind VP or on VP. Next, let us understand various possible position of a point in space or on the plane. There are 9 different positions possible for a point in space or on the plane. First position is in first quadrant. Here, point A is in first quadrant. So, point A is defined as above HP in front of VP. Next, point B is in second quadrant. So, in this position, point B is defined as above HP behind VP. Next, third quadrant position. Here, point C in third quadrant, and point C is defined as below HP behind VP. Next, fourth position of point D in fourth quadrant. This position defined as below HP in front of VP. Next, fifth position on HP. Here, point E is on HP and in front of VP. Next, sixth location. Here, point F is on HP and behind VP. Next, seventh position is point G. Here, point G is on VP and above HP. Next, eighth position is point H. Point H is on VP and below HP. And last, ninth position is point I, and here point I is on HP and on VP. So, this is the maximum 9 possible location of a point in space or on the planes. 4 position in 4 quadrant, 2 position on HP, 2 position on VP, and 1 position on HP and VP both. So, this is the end of this session. See you soon in next coming video lecture. Thank you.